Hello everyone. So I think in the last video I stopped at this particular slide. Let's get started from here. So in this particular query, we are trying to get an SQL query for the following question. We want to determine the names of all the instructors whose salary is greater than some instructor of the computer science department. Okay. Okay. So let's see how do we do this. Okay, so here we have taken two copies of the instructor relation. Okay, so one copy is T and the other copy is S, right? In for one of the copies, more specifically the copy of S, what we have done is that we are performing a select operation on the department name, and we set the selection condition as S dot department name is equal to computer science. So here essentially what we are doing is that this copy of the instructor relation, the copy S, we are performing this select operation on department name, and essentially now the copy S contains only the tuples from the computer science department. Okay, this is the way to think about this SQL query. Now over here, as I always say, that whenever you are writing two relation names like this, you are essentially creating an Cartesian product conceptually. Again, I would like to say the word conceptually. So now let's create this Cartesian product, conceptual Cartesian product between a copy T of the instructor relation and another relation which is essentially containing all the tuples from the computer science department, right? Now in Cartesian product, every tuple in this copy T is matched against every tuple in this copy S, right? And now, we for each tuple we would go forward and then we'll check this particular clause. Okay, so remember that for all the tuples in this Cartesian product, this is already true because conceptually we said that S is something where this is happening, but in reality the execution wise this cross product may happen first, and then for every tuple you do this, right? So I'm just breaking the select condition so that you can understand it better, right? So in our explanation, what we are saying is that S is just the tuples corresponding to the computer science department, and then we are doing a cross product with the instructor relation. That means all tuples over here are matched against the tuples of the computer science department, right? Now for all these matchings which are going to sit in your Cartesian product space, for each of those tuples you are going to perform this check. If T dot salary is greater than S dot salary, if this is true, the tuple passes, right? So now the way to think about this is that let's assume some instructor in, let's say, biology department. Okay, so and for sake of example, assume that uh, that particular instructor, the salary of that particular instructor is less than all the salaries in the computer science department. Let's, for sake of example, that is the case. Then what will happen is that that particular instructor ID from the biology department, when that tuple gets matched against all the tuples of this computer science folks here in sitting in S, then for that guy this will never be true, right? Because we are saying that his or her salary is less than all the salaries that we see in the computer science department. Similarly, any instructor from the copy T, if the salary of that person is less than the salary, if it is less than all the salaries of the computer science department, then that will never get matched. In fact, less than or equal to, right? If you have an arbitrary tuple, let's say from physics department or maths department, the salary is less than or at best equal to the salaries in the computer science department, right? So for all those people whose salaries are less than all the salaries in the computer science department, those tuples from the Cartesian product, they will never get passed. They will never pass this where condition, right? And for all the other tuples in the instructor table, if their salary is greater than at least one salary in the computer science department, that will pass out. Okay, so that will pass up, right? And for all those tuples, from those tuples you take out the name attribute. In order to make it little bit more interesting, let's change this query a little bit. Find the names of all the instructors from non CSC department who have a salary higher salary, who have an higher salary than some instructor in the computer science, right? So now let me put one another. Okay, let me just make it easy. Okay, so let's say that no T dot department name not equal to CSC, right? I think if we do this, then it's little bit more logical, yeah, probably more meaningful. Okay, so here what we are doing is, okay, here what we are doing is we are interested in names of all the instructors who are not from the CSC department, and they have an salary which is higher than at least one instructor of the CSC department, right? So now what I have done here is that this copy T of the instructor, I am passing copy this particular T through this selection condition, wherein I'll filter out all the tuples which are from the CSC. So now this copy T will contain tuples from only the non CSC departments, and S contains tuples only from the CSC department, right? Now you do that cross product join which I was talking about, and then an instructor from this copy T, if his or her salary is less than or at best equal to all the salaries in the computer science department, that tuple will not pass through this where clause. All the other tuples will pass through, and for those tuples, you select the name column, and I'm not sure, perhaps the schema may have duplicate names. For example, two instructors from different departments may have same name. So in that case, we are just putting a distinct over here, right? I know this is a bit more complicated because this is self join. Self joins are a little bit always non trivial to understand. I would say that create small data set, right? Have maybe 3 tuples from CS department and maybe 4 tuples from non CS department. Put in some salary values over there, and then try to execute this query, right? So first put in this part, then put in this part, and then create that cross product space, and then see which tuples pass through this particular class, and then finally you project it out, right? So you'll understand it much more better. And of course, if you have any doubts on this self join, you're more than welcome to get back to me. Okay, so okay, string operators. So SQL has a pretty good support for string operations. Okay, uh, you can have pretty fancy things like select name from instructor, where name like percentage DAR percentage. That means the name has this substring DAR with something coming in the front and the after, right? And if you have to match percentage as it is, then you put the escape character, right? And a little bit more things like For example, if you want to find all the strings which start with the prefix intro, so then you write intro percentage. So this percentage matches any character, or you know uh, actually one or more characters. To be more precise, it matches any substring. Underscore matches a single character. It's more like wild cards. If you have used wild cards back in your regular expressions in the operating systems class and shell programming, it's quite close, right? Okay, so I'm not going to go into details of all the possible string operations that you can do. All I would like to say is that it's pretty detailed, right? You can do substring matching with some prefix, some suffix, and all of that. A lot of things which you can think about in string operations, or with regards to string matching, you can do that in SQL, right? It's fairly detailed, right? I would strongly recommend you to to read the Corth textbook, this chapter on SQL. They have a fairly detailed section on what all can be done using the string operations in SQL. Okay, now let's go forward. Okay, another small thing here. If you want to order the tuples which are displayed, you can use this clause as order by. The way to think about is that this order by clause conceptually would be executed at the end. Okay, so let's say you have a query like this: select distinct name from instructor, order by name. So so the way to think about this is that you take all tuple from the instructor, you project the name column of it, apply the distinct operator on that, and then whatever is the final set, you order that set by name. Okay, and you may also define ordering in descending order or ascending order, right? So I think your textbook says that ascending order is the default, but I think you may have to check with your the installation that you have. These things keep changing across different distributions. Okay, it's pretty straightforward. Only thing to remember is that the order by clause is executed at the very end. We execute the entire query, and the result is ordered. This is not the odd. When I say order by, the actual table is still a set or a bag, right? There the ordering does not matter. This order by clause is only for the display purposes of the results. Okay, go forward. Yeah, I think the next couple of slides, I have some examples on the set operations in SQL. Right? So let's say that I want to find all the courses which were floated in fall 2009 or in spring 2010. I think this terminology is from US terminology. When I say fall, I think it's the first semester in an academic year, and spring is the second semester in the academic year, right? So this is really 2009 semester 1, and instead of spring 2010, I think you should, in the terminology of IT Ropar, we should write semester 2 of the annual year 2009 2010. But I think for explanation purposes, I think it's a fair thing, right? So fall is the July to December part, and spring is the Jan to May part of the academic year. Okay, so the way this query you can do is that you select all. Okay, so I think it's best if I show you the schema once. Okay, so as per the schema, if you want to get those courses, I said that whenever a course is offered, a, a corresponding tuple or tuples are put in this particular table, the section table, because a course can have more than one sections, and if you have only one section, then course section ID will by default be just one. Semester is that fall or spring that I was talking about, the year, where that particular course, what was the room number, CSE department room number CS01, something like that, and what time, right? So whenever a course is offered, the at least one tuple comes into this section, and more than one tuples come if the course has multiple sections, right? So we all have to, when we are answering this query, we have to look for the tuples in the section table, right? So we see the tuples in the section table, and then we pass those tuples through the select operator, where my condition is that semester is equal to fall and year equal to 2009, right? So after this sigma operator is done, you perform the uh, you know uh, you perform the project operator, course ID. You take out the course ID, right? And then similarly, uh, for the second one, or I said or, so that means for the spring 2010, again you take all the tuples from the section, and put them through the select operator, where semester is equal to spring and year equal to 2010, and after you filter those out, you do a projection on the course ID, right? So now this course, we want the courses, which ran either in this or in this, right? So conceptually speaking, my answer is the union of these two sets. Okay, so I use the union keyword here. uh, I think I have said this multiple times. Whenever you're performing the union, you have to make sure that the schema of the relations which you're performing union, they absolutely have to be same, right? A slightly different query. Let's say that you want to find all the courses that were offered in 2009 and in spring 2010. Right? So here it was or, and now it's and. So when you had or, you had to do union operation, and when you have the and, you have to perform the intersect operation, right? So again, same, the first part and the second part of the query, they are identical, right? So you are taking out here, you are taking out all the courses which were offered in fall 2009, and in the second part here, you are taking all the courses which were offered in spring 2010. Now, if you want to find courses which were offered in both fall 2009 and spring 2010, you perform an intersect operation, right? Okay, let's go forward. Okay, so here, we have more examples on set operations, right? We want to find, let's say, something like this: find the largest salary in the instructor table. Of course, you can use max operator and all that, but I'm sort of stretching that this query to show you that this kind of query can be done using set operations also. Okay, it's just an example. Okay, so let's see how do we do that. So we are sort of building up here. So let's pick the first query here. So first, let's say I try to find the salaries of all the instructors that are less than the largest salary in the instructor table. Now, how do I do that? It's a self join, right? So whenever you have a relation, when you have a condition like this, right, it's intuitive that you have to perform some kind of a self join. So when you have to do a self join, you pick up two copies of the instructor, T and S, you create the Cartesian product, and then for each tuple of those Cartesian product, you do this. You check if T dot salary is less than S dot salary, right? And if it is true, then that passes your selection condition. Otherwise, no, right? So when you have a condition like this, what is it actually happening? Which tuples will actually pass through, or which tuples will not pass through? So just let's just check that. So instructor is one relation, and somebody, or more than one people also will have the largest salary in the whole table, right? It's in integer or in a real range. So somebody will have the highest salary, right? So let that be some tuple ti, right? Now what will happen is that if that ti will get matched against all the tuples of this copy s. Now given that this tuple ti has the largest salary, what will happen is that when ti is matched against all the tuples of s, for none of the tuples in the Cartesian product space, this T dot salary, or to be more precise, I would say Ti dot salary would be less than S dot salary, right? So in a condition like this, the guy with the largest, or uh, if you have more than one person with the largest salary, then all those people, they will not match against any tuple from the relation S as per this condition. Okay. So then what will happen is that when you finally do this select distinct T dot salary, what you will get is that you will get the set of all the salaries which are appearing in your instructor table, but not the highest salary that exists in the instructor table, because as I explained, the tuples which have the highest salary will not pass through this, because they would not exist any tuple in my relation in my copy S such that Ti or Tj salary is less than S dot salary, right? So the guy, the faculty with the highest salary will not match with any salary here as per this condition. I wrote here less than, right? So now after from the Cartesian product, the people with the highest salary are sort of removed out, right? And then you project the result on T dot salary. So essentially, you are getting all the salaries uh, which are there in the instructor table, but the resulting set does not contain the highest salary in that, right? So that is the first query. Now second query is pretty straightforward. You take out all the salaries which are available in the instructor table, right? So this set 2 contains all the salaries. Set 1 contains all the salaries except the highest salary. There more than one faculty can be getting that highest salary, doesn't matter. Still, the result of here is the set of all the salaries, except the largest guy. Okay. Now if I do this difference operator, select, for sake of simplicity I wrote like this, but if instead of this, if I had written select distinct salary from instructor, except is that minus operator that I was talking about in relational algebra, right? So if I had written like if second query minus the first query, so now how would this work? Just as in relational algebra, in the minus operator, if you want to find set A minus set B, the output is all the tuples in set A which are not in the set B, right? So now what does my set A contain? Set A contains all the salaries on the instructor table. Set B contains all the salaries except the largest salary, right? So now if you do the difference between these two, the output of this will be the largest salary in the instructor table, right? So of course, there are much more easier ways of doing computing the largest salary, but I just wanted to illustrate this except operator. Sometimes it's of real value, right? So This was just an use case to illustrate that. Okay, hope you understood this. Okay, let's go forward. Okay, some more minor details over here. So set operations, union, intersect, and except, they automatically eliminate all the duplicates. That's how the standard they have implemented. And if you want to retail the duplicates, that means, if you want to go for the bag style of union, intersect, and except, you have to use the keyword union all, intersect all, and except all, right? So that's the way. By default, they convert bags to sets when you are using union, intersect, and except operator in SQL. If you want to have the uh, bag model of union, then you have to use the phrase union all. And similar is the other case. Okay. Okay. So next, I think we have a sample query here. This is fairly bit complicated. I'll try to break it down. So take your time to understand this nicely. So in this schema, we have four tables. I think I have covered this schema before. So you have classes. So classes, as I said, it's like a blueprint of the ship design. So you have the class name, type of the ship, the country who designed this blueprint, some other details of the blueprint, like number of guns, bore, displacement of the ship, and all that. Now, we pick a blueprint and we create a ship out of it, right? So whenever you create a ship, you put a tuple in this relation, and the attributes are you have a name of the ship and the class, the blueprint to which it belongs, and the year in which it was launched. And then you have two other tables, the one being the battles information. That means, you just battles in which ships were participating, and battles have just name and year. Name is the primary key, and similarly her ship name is the primary key. I think for this table, class is the primary key, right? So whenever ships participate in battles, tuples are inserted into this outcomes table. So outcomes table, you have ship name, battle in which it participated, and what was the result after the battle. The result could be either okay, sunk, or damaged, right? Now, our query is that we want to find all those ships which were damaged in one battle. That means the ships participated in at least one battle and they were damaged in that battle, but they were later used in some other battle as well, right? So let's see how do we do that. I think this is just English thing which I have written. I think probably we should cover here. Okay, so again, a lot of things going on here. Let's slowly see what we want. Okay, so the information that we want, we want the information on the ships, and we want the information on the uh, sorry, we want the information on the battles and the result, right? So our tables of interest for this query will be just the battles and the outcomes, right? We did not have to return any other details of the ships. So that's why we are not including the ship table or the class table. We are just interested in the name of the ships, right? And of course, battles. So battle has to be there, and most importantly, outcomes, because in outcomes only you have this information on damaged and whether they fought again or not, right? Okay, so for this query, battles and outcomes is just enough. Okay, so as I always say, you start from the from portion of your SQL, right? So let's see this, let's break it down. So let's try to first find out all the ships that were damaged in one battle. Let's just take this. Ships that were damaged in one battle. Now, how do we do this? So I would have to join battles and outcomes, right? And if I have to join battles and outcomes, what would I join on? I'll join on battle name, right? So battles dot name and outcomes dot battle, right? So this is the only way in which you can join these two tables, right? So you'll join these two tables, and then you are interested in the ships which were damaged. That's the step one, right? So for that, let's take one copy of outcomes, one copy of battles, okay, and create the cross product and do the join, means b dot name equal to o1 dot battle, right? So so from that Cartesian product between o1 and b1, you are sort of filtering out. So essentially you are joining the outcomes copy o1 with the battles copy b1, right? So you perform the join between those two, right? So that means for every outcome you have the details of the battle here, right, after the join. And then you are performing another select operation in which you are throwing out all the tuples where the result is not damaged, right? So you are interested only the ships which were damaged. So this portion of the query, what it is doing is it takes a copy of the outcomes table, it takes a copy of the battles table, computes a join between them, and then and join condition is simple, straightforward, equi-join on the battle name, and then it takes out all the tuples where the result was damaged, right? So after this stage you have a list of you have a set of tuples where the ships got damaged, right? That was the first part. Now in the second part, what we want is out of these damaged ships, we want to find out if they later fought in another battle or not. Now, how do we do that? Right? So, let's take another copy of outcomes O2, another copy of battles B2, right? And do the do the cross product between O2 and B2, and then select the uh, tuples in the join on the basis of name, right? So now if you just see this part, right? So this contains, conceptually after this part, you have the list of all the tuples corresponding to all the ships which got damaged, right? And this part just contains ships which participated in some battle, right? Now we want to compute a join between the this brown set of tuples and the blue set of tuples, right? And on that, in fact, let me change this color so that it will be much more. Okay, so we want to perform a join between the blue set of tuples and the brown set of tuples, and my condition is that uh, ship which ship which is here, you know, and it should have participated in another battle, right? After being damaged, right? Now, how do we do that? So this contains the list of all the battles. It's basically ship and battle in which it which participated. That's all, right? And here you just have the ships, which participated in a battle and they got damaged. Now you just want to see that a tuple from here should get matched with a tuple from here only if uh, the blue tuple has an year greater than b1 dot year, right? So if that is the case, what happens is that this particular ship, participated in another battle whose year is greater than the year in the b1 join o2. So you essentially basically have uh, two tables. One is B1 join O1, the other table is B2 join O2, right? And on B1 join O1, you have put in a filter says that O1 dot result should be damaged. So basically, you just have a list of all the damaged ships, right? And then B2 is just a list of all the battles which ships have fought. It's basically joined between this and this, right? So these are just your two results, two conceptually two tables that you're working with. So one is B1 join O1, the other one is B2 join O2, right? So now you are actually performing a Cartesian product between the results of these two joins, right? And then you are performing a select condition, and that selection condition is that B2 dot year should be greater than or equal to B1 dot year. So if B2 dot year is greater than B1 dot year, right, then that means the corresponding tuple from the B copy, the battle was fought in a different year, right? And if the year was same, you're just seeing that the name was different, okay? And then you have to match that it was indeed the same ship which was participating, right? So again, I think we should start from this part. So you have your B1 join O1 result, this one, and you have this B2 join O2. Okay. Now a tuple from here is matched against a tuple from here, right? And then you are performing all these select operations. So if let's take a tuple T1 from here joined with T2 from here, right? So the first thing I check is that whether O1 dot ship is equal to O2 dot ship or not. That means whether it was the same ship or not, right? Now once it is the same ship, I check whether the battle name is different or not, right? And then the third thing which I check is that B2 dot year should be greater than or equal to B1 dot year. Now this is important because it may happen that there was a ship S1 which fought in a battle in, let's say, 2000, and it was okay, and then later fought in a battle in the year 2010, and then it was damaged. But we don't want ships like this. We want the ships which fought in a battle, they got damaged, and then later fought in another battle. They may get sunk or okay or damaged, does not matter. But they just have to live to see another day, that kind of a thing. So that part is this condition, right? The other, these two things, B1 dot name not equal to B2 dot name, it is basically saying that tuple from this brown set of tuples and blue set of tuples, that means the ship participated in at least two battles, right? And it is the same ship, right? Now this part is actually checking this condition, later fought in another battle. So that's how it works. Okay, so I would say, take your time, digest everything. Don't try to mug it up, as I always say, right? So this is highly, conceptual. There is no black magic going on here. You should be able to, break everything into little pieces and then, sort of digest the material like that. So after after you get all those interesting tuples, you just project on the ship name because that's what you are interested in finding. Okay. Again, go through this. We will when we conduct the live sessions. I expect you to come up with doubts. How this part is working. If you are not clear, you should come to me and then ask questions. Otherwise, I'll not know where you are lacking.